Let's learn about the Pythagorean theorem. We have a squared plus b squared equals c squared. That's the Pythagorean theorem. So we're going to talk about what it is, when can I use it, why do I use it, how do I use it, and we'll do a couple practice problems. Let's get ready. You're going to need paper, pencil, and calculator. And first off, what is the Pythagorean theorem? It's a relationship among the sides of a right triangle. So it's how they are all related to each other. And it's related by the sum of the squares of the sides of a right triangle will add to the square of the hypotenuse. Well, that's a lot of words. So we can say it much better with our letters. It's a squared plus b squared equals c squared. It only works on a right triangle, so you need to have the right angle. If you remember, when we are labeling in geometry, capital letters for angles, so it's angle A, angle C, and angle B, and then lowercase letters for side. So across from the C is a lowercase c. Across from the A, angle A is side A, and across from angle B is side B. So when we're doing the Pythagorean theorem, we need to make sure we always have C as the hypotenuse. So go to your right angle and then go across from it, and then you'll have the hypotenuse. Because sometimes you're looking for the hypotenuse, but sometimes you're given the hypotenuse. Remember that A and B are called legs, and they can interchange. So when do I use the Pythagorean theorem? You only use it on right triangles. So you'll either have to be told that they are perpendicular or have a right angle box in order to be able to know that you can use the Pythagorean theorem. Why do we use Pythagorean theorem? We use it to find a missing side. So we have three variables, A, B, and C, and one of them will be missing. It's not always going to be C, so you do have to pay attention for that. How do we use the Pythagorean theorem? Well, A and B are the legs. C represents the hypotenuse, which is always across from the right angle and always the longest side. We're going to plug in what we know, and then we'll solve. So let's look at this example. Here I have a right triangle, and across from the right angle is the x that we're looking for. So I'm going to write out my letters. A squared plus b squared equals c squared. Again, it doesn't really matter what you pick for A or B, but I'm going to pick those. We'll call our hypotenuse C. So in this case, I am looking for the hypotenuse. So I'm going to plug in 12 squared plus 6 squared equals c squared. 12 squared is 144. 6 squared is 36. And then when I add those together, I get 180 equals c squared. So it doesn't just equal c, it equals c squared. So we have to figure out a way to undo something that's squared. And when you want to undo something that's squared, you're going to take the square root. In algebra, we have to do it to both sides. So I'm just going to rewrite this. I'm going to switch the order around. Same thing there. So c squared equals 180. When I take the square root of c squared, I'm going to get c. And then I have to remember to take it on the other side as well. So this becomes the square root of 180. Pick up your calculator, find that square root button, and go ahead and hit it. We want to do 1 decimal place. So this comes out to be about 13.4. Did you get that? All right, let's try another one. I'm going to go to my right angle. I'm going to go across from my right angle, and my 45 this time is C. So now I have C. Be careful. Do not just see the two numbers and jump right to 20 squared plus 45 squared equals C squared. That's not correct. So that's why you always have to identify your right angle first so you can find your hypotenuse. So I have A squared plus B squared equals C squared. I'm going to call A 20 and X B. So I have 20 squared plus b squared equals c squared, which is 45 squared. 20 squared is 400. 45 squared is 2025. So it's not as easy as the last one because we could just work, we had all the numbers on one side. Just remember your algebra rules. We're trying to get to the b squared, so I want to subtract 400 from both sides. And now I have a statement that says b squared equals 1,625. We want to undo the square, so I'm going to square root both sides. You can hit that on your calculator, and you should get about 40.3. You do want to make sure it makes sense. This is my leg, which is smaller than my hypotenuse, so that's okay. We wouldn't want it to be bigger than 45 because then we did something wrong. And on this example, I just turned it a little bit for you, so it wasn't the same orientation. So find your right angle, draw across from that, and that's going to be my C. If you also notice, I changed my letters from A, B, and C to R, K, and L. I didn't want to give it away. So I'm going to have 16 be my A and X be my B. Again, that one doesn't matter. So with A squared plus B squared equaling C squared, I'm going to plug in my 16. I know my hypotenuse, which is my C. 16 squared is 256. 24 squared, that's supposed to be a 24.5, and I'm just going to switch that. I don't know why the 0.5 didn't show up, just because that's what I have on my notes. So when I square this, I'm going to get 600.25, and then I'm going to subtract 256 from both sides. In this example, I just wanted to give you a decimal. You'll have your calculator, so you'll be okay. So B squared is going to be 344.25. I want to undo the square, so I'm going to square root both sides. And my calculator tells me it is about 18.6. 18.6, yeah, that does make sense. It's smaller than the 24.5, so we are good. So to recap the Pythagorean theorem, it's only used on right triangles. You do need to have that right angle mark. C has to be the hypotenuse across from the right angle. And in order to undo something that's squared, you're going to take the square root. Nice job.